Welcome to Saitechinfo channel, my dear students. In this session, I'll be discussing about Wheatstone Bridge. Wheatstone Bridge generally consists of four resistors connected in a rectangular loop. A galvanometer is connected diagonally. So the resistors are marked as zigzag lines. We have the junctions A, B, C and D. P, Q, R and S are the resistors. You know the resistance, the unit of resistance is ohm. Here G represents galvanometer. Of course, it also indicates the resistance of the galvanometer. Now the junctions A and B are connected to a battery. That has positive electrode anode and negative electrode cathode. That is represented as E, representing the potential provided externally. We have positive and negative electrodes in the battery, and the current direction should be properly indicated. It is represented by I. So from the junction A, current is emerging, and at junction C, the current is approaching that junction C. You know, A, B, C, D are the junctions. I represents the current. Its unit is ampere. So we need to consider the two types of loops. One is A, B, C, D, A, that is a rectangular loop. The other one is A, B, D, A triangular loop. Now let us apply Kirchhoff's voltage rule, represented as KVR here. We know, according to Ohm's law, E is equal to IR. V is equal to IR. The potential is equal to the product of current and resistance. And we need to represent the current passing through these resistors. Let me represent I1 as the current passing through P, the resistor, I2 the current passing through R, I3 the current passing through Q, I4 the current passing through S, the resistor. Of course, we need to consider the potential across the resistor P, which is nothing but the product of current passing through that resistor into the resistance P. So it is, let me say, E1 is equal to I1 into P. Similarly, E2 is equal to I2 into R. E3 is equal to I3 into Q. And E4 is equal to I4 into S, where S is the resistance. I4 is the current passing through that resistance. Let us consider the triangular loop ABDA. Let us apply the KVR, Kirchhoff's voltage rule. So the sum of potential in a loop is 0. The sum of product of potential and current is equal to 0. So Ig is the current passing through the galvanometer. So Eg is the potential difference across the galvanometer. So that G represents the resistance of the galvanometer. So let us apply the KVR product of I1 and P, that is I1P plus IgG, but in the third case it is going in the reverse direction, the current is going in the reverse direction, so we have to put minus I2 into R is equal to 0. That is I2 into R is equal to 0. Why I put the minus sign? Because the current is in the opposite direction. So at B and D there is no change in potential. It means the potential difference across G is 0. Therefore Eg is equal to 0 and Ig into G is equal to 0. But G is not equal to 0 because it has certain resistance. But the product of Ig into G is equal to 0. It means Ig is 0. So let us consider that equation as 2 . So when this Ig is equal to 0, so I1P plus 0 minus I2R is equal to 0. Therefore, I1P is equal to I2R. So we have considered the triangular loop ABDA. Now let us proceed with the rectangular loop, that is A, B, C, D, A. Let us call it loop ABDA, and the other one is loop ABCDA. So ABCDA loop consists of 4 resistors P, Q or S. So we need to consider the sum of product of potential across those resistors in and the respective resistors, and we need to include appropriate sign for current also based on the direction of the current. So I1P, let us apply KVR, I1P plus I3Q minus, why? Because it goes in the opposite direction. The current goes in the opposite direction. So minus I4S. And similarly in the opposite direction, I3 minus I3R. So let us represent that equation by 3. Let us substitute equation 2 in equation 3. So the I1P can be replaced. Instead of I1P, you can take I2R. So I2R can be replaced by I1P. So that I1P can be cancelled. Therefore, I3Q minus I4S is equal to 0. It means I3Q is equal to I4S. Are you able to follow? You have to watch these types of videos 1 or 2 times in order to understand the concept in a better way. Now let us consider the third equation, I1P plus I3Q is equal to I4S plus I2R. So we have, after all, rearranged the equation. So at B and D, there is no potential difference. Therefore, I1 is equal to I3. Similarly, I2 is equal to I4. So we can suitably replace this in equation 3 so that we can bring it in terms of I1 and I2 only. So I1P plus, instead of I3, I can put I1. I1Q is equal to, instead of I4, we can write I2. So I2S plus I2R. I1 being common, that can be taken outside the bracket. So I1 into P plus Q is equal to, similarly on the right side, I2 is common. Therefore, I2 is taken outside the bracket. So I2 of S plus R. So let us consider this as equation number 5. So let us divide the equation 5 by equation 2 so that we can eliminate the current terms I1 and I2. So I1 of P plus Q divided by I1P is equal to I2 of R plus S divided by I2 R. So we can strike out I1 and I2. Now the equation becomes P plus Q divided by P is equal to R plus S divided by R. So splitting the fraction, results the following equation. P by P plus Q by P is equal to R by R plus S by R. So P can be cancelled. So 1 plus Q by P. Similarly, on the other side, R can be cancelled. So 1 plus S by R. Therefore, Q by P is equal to S by R. Now we can suitably reciprocate. P by Q is equal to R by S. So this is the equation of Wheatstone Bridge, wherefrom we can determine the resistance. Thank you very much. Remember, these are two circular loops. I mean, a rectangular loop and triangular loops. Are you able to understand? Good. Thank you.